The National Electrical Code (NEC) has specific requirements regarding electrical circuits in bathrooms. It's important to understand these requirements to ensure safety and compliance during any electrical work. According to the NEC, bathrooms must have at least one 20-amp general use circuit, as stated in NEC section 210.11 cone. This circuit is intended to supply power to various electrical devices within the bathroom, such as outlets for hairdryers, curling irons, or other appliances. However, a bathroom exhaust fan needs to be on a separate circuit as specified in NEC section 410.31c. This means that the fan should not share a circuit with the general use outlets or other appliances in the bathroom. The rationale for requiring a dedicated circuit for the exhaust fan is threefold. Firstly, the fan draws a certain amount of current, in this case 2.5 amps. Although 2.5 amps may seem small, it can contribute to overloading the existing 20 amp circuit if other appliances are used simultaneously. Overloading a circuit can lead to overheating of the wires, potentially causing a fire hazard. Secondly, a dedicated circuit ensures that the fan will have sufficient power to operate effectively. This prevents nuisance stripping of the circuit breaker, which can be inconvenient and potentially damaging to the fan motor. Thirdly, a separate circuit allows for easier troubleshooting and maintenance if the fan malfunctions. If the fan stops working, it will be easier to isolate the problem to the fan circuit without affecting other electrical devices in the bathroom. To comply with the NEC, it is essential to install a separate 20-amp circuit for the bathroom exhaust fan. There are several ways to accomplish this. 1. Using a home run circuit, a dedicated circuit that runs directly from the main electrical panel to the fan. 2. Installing a new 20-amp sub-panel in the bathroom which provides a separate source of power for the fan and other bathroom circuits. 3. Running a new cable from the main electrical panel to the fan, creating a dedicated circuit specifically for the fan. It is strongly recommended to follow the guidance and install a separate circuit for the exhaust fan. This will ensure the safety and functionality of the bathroom electrical system. Ignoring this can lead to potential electrical hazards and non-compliance with the NEC. When working with electrical systems, it is always best to consult with a qualified electrician to ensure that the work is done safely and according to code. Electrical work can be dangerous if not performed correctly, so it is important to take all necessary precautions. By understanding the NEC requirements and following the recommendations, a safe and functional bathroom electrical system can be ensured. Now let's delve a little deeper into the technical aspects of bathroom electrical circuits and the National Electrical Code requirements. The NEC, published by the National Fire Protection Association (NFPA), is a comprehensive set of standards and guidelines for electrical installations in the United States. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The NEC is not a law itself, but it is widely adopted by state and local jurisdictions as the basis for their electrical codes. Compliance with the NEC is essential to ensure the safety of people and property from electrical hazards. As previously mentioned, NEC section 210.11 cone requires bathrooms to have at least one 20-amp general use circuit. This circuit is intended to supply power to receptacles, lighting, and other electrical devices in the bathroom. The 20-amp rating indicates the maximum amount of current that the circuit can safely carry. It is important not to overload the circuit by connecting too many devices at once, as this can cause the circuit breaker to trip. NEC section 410.31c specifically addresses the requirements for bathroom exhaust fans. This section mandates that the fan be on a separate circuit, independent of the general use circuit. The rationale behind this requirement is to prevent overloading the general use circuit and to ensure that the fan has sufficient power to operate effectively. The 2.5 amps that the exhaust fan draws can contribute to the overall load on the circuit, especially when other appliances are in use. By placing the fan on a dedicated circuit, the risk of overloading the general use circuit is reduced. Furthermore, a dedicated circuit provides a more stable and reliable power supply for the fan. This can help to prevent nuisance tripping of the circuit breaker, which can be frustrating and potentially damaging to the fan motor. In addition to preventing overloads and ensuring a stable power supply, a dedicated circuit also simplifies troubleshooting and maintenance. If the fan malfunctions, it will be easier to isolate the problem to the fan circuit without affecting other electrical devices in the bathroom. This can save time and effort when diagnosing and repairing the issue. Now, let's consider the options for installing a separate 20-amp circuit for the bathroom exhaust fan versus the home run circuit. This involves running a dedicated cable directly from the main electrical panel to the fan location. The cable should be sized appropriately for a 20-amp circuit, typically 12 American wire gauge AUG copper wire. The circuit breaker in the main panel should also be rated at 20 amps. A home run circuit provides the most direct and reliable power supply for the fan. Secondly, installing a new 20-amp sub-panel in the bathroom. A sub-panel is a smaller electrical panel that is fed from the main electrical panel. It provides a convenient way to add new circuits to a specific area of the house, such as a bathroom. The sub-panel should be sized appropriately for the number of circuits it will serve. A 20-amp circuit breaker can then be installed in the sub-panel to power the exhaust fan. Thirdly, running a new cable from the main electrical panel to the fan. This is similar to the home run circuit option, but it may be more feasible if the distance between the main panel and the fan location is relatively short. Again, the cable should be sized appropriately for a 20-amp circuit, and the circuit breaker in the main panel should be rated at 20 amps. Regardless of which option you choose, it is important to follow all applicable electrical codes and safety practices. The electrical work can be dangerous if not performed correctly, so it is always best to consult with a qualified electrician if you are not comfortable doing the work yourself. In addition to the NEC requirements, there may also be local electrical codes that apply to your bathroom remodel. It is important to check with your local building department to ensure that you are in compliance with all applicable regulations. By following the NEC and the local electrical codes, a safe and functional bathroom electrical system can be ensured. This will provide peace of mind and protect you and your family from electrical hazards. Now we can explore some additional considerations for bathroom electrical circuits and the NEC. One important aspect is ground fault circuit interrupter (GFCI) protection. GFCI protection is required for all receptacles in bathrooms, as well as for certain other locations where there is a high risk of electric shock. A GFCI is a device that monitors the flow of current in a circuit and quickly interrupts the power if it detects a ground fault. A ground fault occurs when electricity flows through an unintended path, such as through a person's body. GFCI protection can prevent serious injury or death from electric shock. When installing a new receptacle in a bathroom, it is important to use a GFCI receptacle. GFCI receptacles have a test button and a reset button on the front. The test button should be pressed periodically to ensure that the GFCI is functioning properly. Another consideration is the placement of receptacles in bathrooms. The NEC has specific requirements for the location of receptacles near sinks and other water sources. These requirements are designed to prevent electric shock hazards. Receptacles should not be located within a certain distance of a sink or shower, as this could increase the risk of water coming into contact with the receptacle. When planning the layout of a bathroom, it is important to take these receptacle placement requirements into account. In addition to receptacles, lighting fixtures in bathrooms also need to comply with the NEC. Lighting fixtures should be installed in accordance with the manufacturer's instructions and should be suitable for the damp or wet environment of a bathroom. Some lighting fixtures may need to be grounded to prevent electric shock hazards. It is important to choose lighting fixtures that are appropriate for the bathroom environment and to install them correctly. Another aspect to consider is the use of arc fault circuit interrupter off-site protection. SIs are similar to GFCIs, but they are designed to protect against arc faults. An arc fault is an unintentional electrical discharge that can occur in a circuit. Arc faults can be caused by damaged wiring, loose connections, or other factors. SIs can detect arc faults and quickly interrupt the power, preventing a fire. While SI protection is not specifically required for bathroom circuits in all jurisdictions, it is becoming increasingly common in new construction and renovations. It is worth considering adding a side protection to bathroom circuits to enhance safety. When working with electrical systems, it is important to use the correct wiring methods. The NEC specifies the types of wiring that are permitted for different applications. For example, non-metallic NM cable, also known as Romex, is commonly used for residential wiring. However, NM cable is not permitted in certain locations, such as underground or in damp or wet environments. In these cases, other types of wiring, such as underground feeder of cable or conduit, may be required. It is important to choose the correct wiring method for the specific application to ensure safety and compliance with the NEC. Furthermore, proper grounding is essential for all electrical systems. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electric shock hazards. The NEC has detailed requirements for grounding electrical systems. These requirements include the use of grounding electrodes, grounding conductors, and bonding jumpers. It is important to follow these requirements carefully to ensure that the electrical system is properly grounded. When making electrical connections, it is important to use the correct connectors and to make sure that the connections are tight and secure. Loose connections can cause overheating, arcing, and even fires. The NEC specifies the types of connectors that are permitted for different applications. It is important to use these connectors correctly and to tighten them to the proper torque. Finally, it is always a good idea to label electrical panels and circuits. This can make it easier to identify circuits and to troubleshoot problems in the future. The NEC requires that electrical panels be labeled with the circuit numbers and the areas or devices that they serve. It is also helpful to label the circuit breakers in the panel with the same information. By following these additional considerations, a safe and functional bathroom electrical system can be ensured. This will provide peace of mind and protect you and your family from electrical hazards. Remember, when in doubt, consult with a qualified electrician. Electrical work can be dangerous if not performed correctly, so it is important to take all necessary precautions. Always prioritize safety when working with electricity. Now to explore the implications of not adhering to the NEC requirements and potential consequences of ignoring the code and the inspector's recommendations. Firstly, safety risks. The primary reason for the NEC requirements is to ensure the safety of people and property. Ignoring these requirements can create dangerous situations that could lead to electric shock, fires, or other hazards. Overloading circuits, using improper wiring methods, or neglecting GFCI protection can all increase the risk of electrical accidents. Secondly, property damage. Electrical fires can cause significant damage to property. An electrical fire can quickly spread throughout a building, causing extensive damage to walls, floors, ceilings, and personal belongings. In some cases, electrical fires can even result in the total loss of a building. Thirdly, legal liability. If a building does not comply with the NEC and an electrical accident occurs, the property owner could be held liable for damages. This could include medical expenses, lost wages, property damage, and even legal fees. In some cases, the property owner could also face criminal charges. Fourthly, insurance issues. Insurance companies may deny coverage for damages caused by electrical fires if the building does not comply with the NEC. This could leave the property owner with significant financial losses. Fifthly, difficulty selling the property. A building that does not comply with the NEC may be difficult to sell. Potential buyers may be reluctant to purchase a property that has known electrical code violations. This could lower the value of the property and make it harder to find a buyer. Sixthly, fines and penalties. Local jurisdictions may impose fines and penalties for violations of the NEC. These fines can be substantial and can add up quickly if the violations are not corrected promptly. Seventhly, delayed or denied occupancy permits. If a building does not comply with the NEC, the local building department may delay or deny occupancy permits. This can prevent the property owner from using the building for its intended purpose. Eighthly, increased insurance rates. Insurance companies may charge higher insurance rates for buildings that do not comply with the NEC. This is because non-compliance with the NEC increases the risk of electrical accidents. Ninthly, voided warranties. Some manufacturers may void warranties on electrical equipment if it is not installed in accordance with the NEC. This could leave the property owner responsible for the cost of repairing or replacing the equipment. Tenthly, reduced property value. A building that does not comply with the NEC may have a lower property value than a comparable building that does comply. This is because potential buyers may be willing to pay less for a property that has known electrical code violations. For all these reasons, it is essential to comply with the NEC. Ignoring the code can have serious consequences, including safety risks, property damage, legal liability, and financial losses. Now we can further expand on the practical steps involved in installing a dedicated circuit for a bathroom exhaust fan, ensuring compliance with the NEC and best practices. Before starting any electrical work, it is crucial to turn off the power to the circuit at the main electrical panel. This can be done by switching off the circuit breaker that supplies power to the bathroom. It is also a good idea to test the circuit to make sure that the power is off before starting work. This can be done using a voltage tester. Next, determine the best location for the new circuit breaker in the main electrical panel. If there is an open space in the panel, you can install the new breaker there. If there is no open space, you may need to install a subpanel. A subpanel is a smaller electrical panel that is fed from the main electrical panel. It provides a convenient way to add new circuits to a specific area of the house. After that, run the new cable from the main electrical panel to the location of the bathroom exhaust fan. The cable should be sized appropriately for a 20 amp circuit, typically 12 American wire gauge AUG copper wire. The cable should be run through walls, ceilings, or floors in accordance with the NEC. Where the cable passes through studs or joists, it should be protected by nail plates to prevent it from being damaged by nails or screws. Once the cable is run to the fan location, install a junction box for the electrical connections. The junction box should be mounted securely to a stud or joist. The cable should be brought into the junction box through a cable clamp. Next, make the electrical connections in the junction box. Connect the black wire from the cable to the black wire on the fan. Connect the white wire from the cable to the white wire on the fan. Connect the green or bare copper wire from the cable to the green grounding screw on the fan. All connections should be made using wire connectors. The wire connectors should be sized appropriately for the size of the wires being connected. Tighten the wire connectors securely to ensure a good electrical connection. Now install the new circuit breaker in the main electrical panel. The circuit breaker should be rated at 20 amps. Connect the black wire from the new cable to the circuit breaker. Connect the white wire from the new cable to the neutral bus bar in the panel. Connect the green or bare copper wire from the new cable to the grounding bus bar in the panel. All connections should be made securely. Then turn on the power to the circuit at the main electrical panel. After turning on the power, test the fan to make sure that it is working properly. Use a voltage tester to check the voltage at the fan. The voltage should be approximately 120 volts. After that, label the new circuit breaker in the main electrical panel. The label should indicate that the circuit breaker supplies power to the bathroom exhaust fan. This will make it easier to identify the circuit in the future. Finally, have the electrical work inspected by a qualified electrical inspector. The inspector will verify that the work was done in accordance with the NEC and local electrical codes. This will ensure that the electrical system is safe and compliant. Remember to take all necessary safety precautions when working with electricity. If you are not comfortable doing the work yourself, hire a qualified electrician. Now to expand on the importance of using the correct materials and tools when working with electrical circuits, and potential consequences of using substandard or inappropriate items. Firstly, wiring. As mentioned earlier, the correct gauge of wire is crucial. Using a wire gauge that is too small for the circuit's amperage can lead to overheating, insulation damage, and potentially a fire. Copper wiring is generally preferred over aluminum due to its better conductivity and resistance to corrosion. The type of insulation on the wire, such as thermoplastic high heat resistant nylon (THHN) or thermoplastic high heat resistant, water resistant (THWN) should also be appropriate for the environment. Secondly, circuit breakers. Using the wrong type or rating of circuit breaker can be dangerous. A circuit breaker that is rated too high for the wiring can allow the circuit to become overloaded, increasing the risk of fire. A circuit breaker that is not designed for the specific electrical panel may not fit properly or function correctly. Thirdly, receptacles and switches. Using receptacles and switches that are not rated for the voltage and amperage of the circuit can lead to overheating, arcing, and potential fire hazards. GFCI receptacles should be used in bathrooms and other areas where there is a risk of water exposure. Fourthly, connectors and fittings. Using the wrong type of connectors or fittings can result in loose connections, which can cause overheating and arcing. Connectors and fittings should be rated for the type and size of wire being used. Fifthly, junction boxes. Junction boxes should be made of a durable, non-combustible material such as metal or plastic. They should be sized appropriately for the number of wires and connections being made. Sixthly, conduit. Conduit is used to protect wiring in certain applications such as underground or in exposed locations. The type of conduit used should be appropriate for the environment. For example, rigid metal conduit should be used in areas where the wiring is subject to physical damage. Seventhly, tools. Using the wrong tools can damage wiring, connectors, and other electrical components. It is important to use tools that are specifically designed for electrical work, such as wire strippers, crimpers, and voltage testers. In addition to using the correct materials, it is also important to use the correct techniques. For example, when stripping wires, be careful not to nick or damage the conductors. When making connections, tighten the connectors securely to ensure a good electrical connection. When installing circuit breakers, make sure they are properly seated in the electrical panel. Using substandard or inappropriate materials can have serious consequences. It can increase the risk of electrical shock, fire, and other hazards. It can also void warranties and lead to code violations. Therefore, it is always best to use high-quality materials that are specifically designed for electrical work. Now we can discuss the importance of proper planning and preparation before starting any electrical work to ensure a safe and successful outcome. Firstly, assess the existing electrical system. Before adding a new circuit, it is important to assess the existing electrical system to determine if it can handle the additional load. Check the capacity of the main electrical panel and the size of the service entrance conductors. If the existing system is not adequate, it may be necessary to upgrade it before adding new circuits. Secondly, determine the load requirements. Calculate the total load that will be connected to the new circuit, including the bathroom exhaust fan and any other devices that will be powered by the circuit. This will help you determine the appropriate wire gauge and circuit breaker size. Thirdly, create a wiring diagram. Draw a detailed wiring diagram showing the location of the new circuit, the wiring connections, and the location of all electrical components. This will help you visualize the project and ensure that you have all the necessary materials. Fourthly, obtain the necessary permits. Contact your local building department to determine if any permits are required for the electrical work. Obtaining the necessary permits will ensure that the work is done in compliance with local codes and regulations. Fifthly, gather the necessary materials and tools. Make a list of all the materials and tools that you will need for the project, including wiring, circuit breakers, receptacles, switches, connectors, junction boxes, conduit, wire strippers, crimpers, and voltage testers. Purchase high-quality materials that are specifically designed for electrical work. Sixthly, review the National Electrical Code, NEC. Familiarize yourself with the NEC requirements for bathroom electrical circuits. This will help you ensure that the work is done in accordance with the code. Seventhly, plan the wiring route. Determine the best route for running the wiring from the main electrical panel to the location of the bathroom exhaust fan. Avoid running wiring through areas where it could be damaged or exposed to moisture. Eighthly, prepare the work area. Clear the work area of any obstacles and protect the surrounding surfaces from damage. Wear appropriate safety gear, such as safety glasses and gloves. Ninthly, turn off the power. Before starting any electrical work, turn off the power to the circuit at the main electrical panel. Test the circuit to make sure that the power is off before starting work. 10thly, inspect the materials. Before using any materials, inspect them for damage or defects. Do not use any materials that are damaged or defective. By following these planning and preparation steps, a safe and successful electrical project can be ensured. This will minimize the risk of electrical shock, fire, and other hazards. It will also help to ensure that the work is done in compliance with local codes and regulations. Electrical work can be dangerous if not performed correctly, so it is important to take all necessary precautions. If you are not comfortable doing the work yourself, hire a qualified electrician. Now to address common mistakes to avoid when working on bathroom electrical circuits to prevent potential safety hazards and code violations. Firstly, overloading circuits. One of the most common mistakes is overloading circuits. This occurs when too many devices are connected to a single circuit, exceeding its capacity. Overloading a circuit can cause the circuit breaker to trip, and in some cases, it can lead to overheating and fire. To avoid overloading circuits, calculate the total load that will be connected to each circuit and make sure that it does not exceed the circuit's capacity. Secondly, using the wrong wire gauge. Using the wrong wire gauge is another common mistake. Wire gauge refers to the thickness of the wire. Using a wire gauge that is too small for the circuit's amperage can cause the wire to overheat and potentially start a fire. To avoid using the wrong wire gauge, consult the NEC or a qualified electrician to determine the appropriate wire gauge for the circuit's amperage. Thirdly, improper grounding. Improper grounding is a serious safety hazard. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electric shock. Failure to properly ground electrical circuits can increase the risk of electric shock. To avoid improper grounding, follow the NEC requirements for grounding electrical systems. Fourthly, using non-GFCI receptacles in bathrooms. As mentioned earlier, GFCI receptacles are required in bathrooms and other areas where there is a risk of water exposure. Using non-GFCI receptacles in these areas can increase the risk of electric shock. To avoid this mistake, always use GFCI receptacles in bathrooms. Fifthly, making loose connections. Loose connections can cause overheating, arcing, and potentially fire hazards. To avoid loose connections, tighten all connections securely using the correct tools. Sixthly, running wiring through wet or damp locations. Running wiring through wet or damp locations can damage the wiring and create a shock hazard. To avoid this mistake, run wiring through dry locations or use wiring that is specifically designed for wet or damp locations. Seventhly, not obtaining permits. As mentioned earlier, obtaining permits is required for many electrical projects. Failure to obtain permits can result in fines and penalties. To avoid this mistake, contact your local building department to determine if permits are required for your project. Eighthly, not following the National Electrical Code, NEC. The NEC is a comprehensive set of standards for electrical installations. Failure to follow the NEC can result in safety hazards and code violations. To avoid this mistake, familiarize yourself with the NEC requirements for your project. Ninthly, working on live circuits. Working on live circuits is extremely dangerous and can result in electric shock or death. To avoid this mistake, always turn off the power to the circuit before starting any electrical work. Tenthly, failing to inspect the work. After completing the electrical work, it is important to inspect it carefully to make sure that everything is done correctly. This includes checking the wiring connections, grounding, and GFCI protection. To avoid this mistake, have the electrical work inspected by a qualified electrical inspector. By avoiding these common mistakes, a safe and successful electrical project can be ensured. Electrical work can be dangerous if not performed correctly, so it is important to take all necessary precautions. If you are not comfortable doing the work yourself, hire a qualified electrician. Now to address some frequently asked questions about bathroom electrical circuits and the NEC, providing clear and concise answers to help homeowners better understand the requirements. Firstly, can I install a receptacle in my shower? No, receptacles are not permitted in showers or within certain distances of showers. This is to prevent the risk of electric shock. The NEC specifies the minimum distances that receptacles must be located from showers. Secondly, do I need a GFCI receptacle for my bathroom lighting? No, GFCI protection is not typically required for bathroom lighting unless the lighting fixture is located within a certain distance of a water source. However, it is always a good idea to use GFCI protection for any electrical device in a bathroom. Thirdly, can I use an extension cord in my bathroom? It is generally not recommended to use extension cords in bathrooms, as they can create a tripping hazard and increase the risk of electric shock. If you need to use an extension cord, make sure it is a heavy-duty extension cord with a GFCI protection. Fourthly, how often should I test my GFCI receptacles? GFCI receptacles should be tested monthly to ensure that they are functioning properly. To test a GFCI receptacle, press the test button. The receptacle should trip, cutting off the power. To reset the receptacle, press the reset button. Fifthly, can I install a ceiling fan in my bathroom? Yes, you can install a ceiling fan in your bathroom, but it must be a ceiling fan that is specifically designed for damp locations. The ceiling fan should also be grounded properly. Sixthly, what is the difference between a GFCI receptacle and a GFCI circuit breaker? A GFCI receptacle is a receptacle that has GFCI protection built into it. A GFCI circuit breaker is a circuit breaker that provides GFCI protection for the entire circuit. Both types of GFCI protection are acceptable for bathrooms. Seventhly, can I install a dimmer switch in my bathroom? Yes, you can install a dimmer switch in your bathroom, but it must be a dimmer switch that is specifically designed for use with the type of lighting fixture you are using. Some dimmer switches are not compatible with certain types of lighting fixtures. Eighthly, what is the proper height for installing receptacles in a bathroom? The NEC does not specify a minimum height for installing receptacles in a bathroom, but it is generally recommended to install them at least 12 inches above the floor. This will help to prevent them from getting wet. Ninthly, can I run wiring through a drop ceiling in my bathroom? Yes, you can run wiring through a drop ceiling in your bathroom, but the wiring must be supported properly and protected from damage. The wiring should also be accessible for inspection and maintenance. Tenthly, do I need to hire a qualified electrician to do electrical work in my bathroom? It is always recommended to hire a qualified electrician to do electrical work in your bathroom, especially if you are not comfortable doing the work yourself. Electrical work can be dangerous if not performed correctly, so it is important to take all necessary precautions. By addressing these frequently asked questions, homeowners can gain a better understanding of bathroom electrical circuits and the NEC requirements. This will help them make informed decisions about their electrical projects and ensure that the work is done safely and in compliance with the code. Now to discuss the importance of documentation and record keeping for bathroom electrical circuits, and how proper documentation can be beneficial for future maintenance, troubleshooting, and home sales. Firstly, wiring diagrams. Create and maintain accurate wiring diagrams of all electrical circuits in your bathroom. These diagrams should show the location of all wiring, receptacles, switches, lighting fixtures, and other electrical components. Wiring diagrams can be helpful for troubleshooting electrical problems and for making future modifications to the electrical system. Secondly, circuit directory. Create and maintain a circuit directory that lists all of the circuits in your electrical panel. The circuit directory should indicate the areas or devices that each circuit serves. This will make it easier to identify circuits and to turn off the power to specific areas when necessary. Thirdly, permits and inspections. Keep copies of all permits and inspection reports for electrical work in your bathroom. These documents will demonstrate that the work was done in compliance with local codes and regulations. They may also be required for insurance purposes or when selling your home. Fourthly, product manuals and warranties. Keep copies of all product manuals and warranties for electrical devices in your bathroom, such as lighting fixtures, exhaust fans, and GFCI receptacles. These documents will provide information about the proper installation, operation, and maintenance of the devices. They may also be required for warranty claims. Fifthly, maintenance records. Keep records of all maintenance and repairs performed on electrical circuits in your bathroom. This includes dates, descriptions of the work performed, and the names of the electricians or contractors who performed the work. Maintenance records can be helpful for identifying potential problems and for tracking the performance of electrical devices over time. Sixthly, photos and videos. Take photos and videos of electrical work in progress, especially before covering up wiring or connections. These photos and videos can be helpful for future reference and for documenting the work that was done. Seventhly, receipts and invoices. Keep receipts and invoices for all electrical materials and services purchased for your bathroom. These documents can be helpful for tracking expenses and for claiming tax deductions. Eighthly, home inspection reports. Review and keep copies of any home inspection reports that include information about the electrical system in your bathroom. These reports can identify potential problems and provide recommendations for repairs or upgrades. Ninthly, appliance manuals. Keep the manuals for all appliances used in the bathroom, such as hair dryers, curling irons, and electric shavers. These manuals often contain safety information and troubleshooting tips related to electrical usage. Tenthly, contact information. Maintain a list of contact information for qualified electricians and contractors who can provide electrical services in your bathroom. This will make it easier to find help when needed. Proper documentation and record keeping can be invaluable for maintaining a safe and efficient electrical system in your bathroom. It can also be helpful for troubleshooting problems, making future modifications, and selling your home. Take the time to gather and organize these documents and keep them in a safe and accessible location. Now to discuss the importance of staying updated and the latest changes to the National Electrical Code, NEC, and how homeowners can stay informed about these changes to ensure compliance and safety. Firstly, subscribe to industry publications. Subscribe to industry publications such as the Electrical Contractor Magazine, EC Magazine, or the National Electrical Code Handbook. These publications provide updates on the latest changes to the NEC and other relevant industry news. Secondly, attend industry events. Attend industry events such as trade shows, conferences, and workshops. These events provide opportunities to learn about the latest changes to the NEC and to network with other professionals in the electrical industry. Thirdly, take continuing education courses. Take continuing education courses on electrical codes and safety. These courses will help you stay up to date on the latest changes to the NEC and to improve your knowledge and skills. Fourthly, visit the National Fire Protection Association (NFPA) website. Visit the NFPA website regularly to access the latest information about the NEC and other NFPA standards. The NFPA website also provides access to the NEC Handbook and other helpful resources. Fifthly, consult with a qualified electrician. Consult with a qualified electrician regularly to get advice on electrical codes and safety. A qualified electrician can help you stay up to date on the latest changes to the NEC and to ensure that your electrical system is compliant with the code. Sixthly, follow industry blogs and social media. Follow industry blogs and social media accounts that provide updates on electrical codes and safety. These sources can provide timely and relevant information about changes to the NEC and other important topics. Seventhly, participate in online forums and discussions. Participate in online forums and discussions about electrical codes and safety. This can be a great way to learn from other professionals and to stay informed about the latest changes to the NEC. Eighthly, review local building codes. Review your local building codes regularly to ensure that they are consistent with the NEC. Local building codes may have additional requirements or modifications to the NEC. Ninthly, network with electrical inspectors. Network with electrical inspectors in your area. Electrical inspectors can provide valuable insights into the interpretation and enforcement of the NEC. 10thly, stay curious and proactive. Stay curious and proactive about learning about electrical codes and safety. The electrical industry is constantly evolving, so it is important to stay informed about the latest changes and best practices. By staying updated on the latest changes to the NEC, homeowners can ensure that their electrical systems are safe, compliant, and up to date with the latest industry standards. This will help to protect their homes and families from electrical hazard.